Hello, my name is Brian Minter, and I wrote my paper on microfibers. This presentation will talk about where microfibers come from, how they reach the environment, and ways in which we can prevent their release into the environment. Plastics are organic polymer derived from petrochemicals. If you look at the bottom of your water bottle, you'll see inside the recycled triangle a number. That number tells you what type of plastic the bottle is made out of. But not all plastics are recyclable, nor are they all properly disposed of. And they can accumulate in water bodies. A particularly insidious form of microplastics in water are microplastics. Microplastics are 5 millimeters in size or smaller, about the size of a sesame seed, and there are two types: primary, industry created, and secondary, fragmentally created from a larger piece of plastic. Primary microplastics can be found in products in your bathroom to products in your garage. In 2015, U.S. Congress passed legislation to eliminate microbeads in exfoliating personal care products. Secondary microplastics, on the other hand, come from a larger piece of plastic, and this occurs when UV light can break down the plastic, making it more susceptible to fragmentation. Ultimately, there are many vectors in which microplastics reach the environment: through accidental spills, incidental to an operation. In the case of secondary plastics, just through the normal wear and tear of products comprised of plastic. Once microplastics reach the environment, they can bioaccumulate. They can go up the food chain from ingestion or the chemical constituents of said plastic. Microfibers are filamentous form of plastic, range in sizes from 6 microns in diameter to 175 microns, and they're so ubiquitous that they've been found in many drinking waters of cities on every continent. These synthetic fibers to note are nylon, first man-made fiber, and polyester, PET, number 1 in the recycle chart. These synthetic fibers have many desirable characteristics, hence you find them in many, many products. For example, clothing. They are weather resistant, UV resistant, and they hold up well. But these synthetic fibers and textiles do break down due to the natural wear and tear of the product, and through the effluent of a washing machine. Laundering cleans clothes not just through the detergent, but also through the mechanical agitation of the fabric. This agitation can create up to 2.2 pounds of fibers for 100,000 people. And this happens because washing machines consist of a pump located at the bottom of the machine to collect the drainage of the machine. As you can see on the right, you see how the pump integrates with the washing machine. Microfibers have a size of 6 microns to 175 microns. The 6 micron range is in the pink, and the 175 is about the size of a piece of sawdust. And it could be captured by commercial filters costing about $8. Putting the two together, you have a pump curve from a Whirlpool pump that can produce 7.9 feet of head at 5 gallons per minute. The pressure loss for the filter at the same rate is about a foot. Additionally, there are other design considerations, such as the type of hose. The corrugated nature reduces the amount of flow or adds head to the flow, the number of curves. But these are issues that are economically viable. So ultimately, economically speaking, you don't need to do much to your washing machine to get a pump to go through a filter. But there are other things, operational hurdles, such as how to dispose of the material collected on the filter. Traditional backwashing may be not viable due to it flowing. So in conclusion, what makes plastic so necessary in everyday life makes it persistent in nature. But washing machines do have the pump capacity to pass through filter and collect said microfibers. Thank you.